So this was the question 1. Question 1 here is saying it's under sets. They're saying given that the sets A is open from -7 to 3 and also B is closed from -3 to 3, closed on both ends, then C is closed at -1 but open at 6. The universal set is simply the whole real number line. They are saying display the following on the number line. That's what they want us to do. So the first thing is to simplify this to see if you are able to reduce it into something that you are comfortable with in terms of operating or introducing the complement throughout. Yeah, so the first one here we're going to have, we'll try to reduce it first. So question 1, I'll take it as A. This is just, they're saying B complement, B union A complement intersection B, then there's a complement, then there's a complement outside there. So the first thing that we do is introduce this complement throughout. This is going to be B complement intersection A, then union B. Is everyone okay on how this comes about? Anyone who is lost? Any set here, any set union an empty set is that same set. So what we are simply looking for is A minus B. This is basically what we're interested in. So this whole thing has been simplified. So we just simplify this by distributing the complement, and from here distributing the B complement. That's what we get here. Then this part gives us empty. Then that's how we are landing to get this. Any questions, guys, here? Anyone who is lost? So if I've flipped it, this here is the same as A intersection B complement I. This is what I've just gotten there. Yeah, it's commutative. B complement intersection A is the same as A intersection B complement. Then according to the intervals given, we are having A is open at -7 and 3 is open. Then your B is simply closed at -3 and also closed at 3. So we're looking for A minus -3 and 3. This is your B. Your B was supposed to be like this. Then the complement of B will just be everything outside B. So this going this side. So the one in red is our B complement. Hope this is okay with everyone. Then I can remove the B complement and just put our A. Our A is from -7 up to 3. It's open there and it's also open there. So what is the intersection here going to be, guys? What's the intersection? Anyone to give it a try? What's the intersection?
-7 open to -3 open.
Just this, right? Just this part here. This is basically what you're going to get. So it's open on both ends. So we're going to say the whole thing. You can now write the whole question that you were initially given. A complement intersection B complement with a complement outside is actually just negative this to negative that. This is what you get. Yeah, so this is how you were supposed to do number 1. That was totaling to 7 marks. Yeah, so this is what was needed. Then apart from this, okay, let me just put it back in case there's anyone who is still copying. The next question was asking, yes, they're saying they want us to display this on the real number line. So these are all separate sets. So this is going to be A intersection B intersection C. The complement is outside this side. That's a rule, right? If you have A minus B, it's always going to be A intersection. The complement is on the right side, on the set, whatsoever set that you have on the right, despite how it's represented. And here, what was on the right was B intersection C. So this is what we're going to get. Then we can proceed to just try it out. So this is number 2 on A. That's A. It was A minus, then there was B intersection this. This changed to become B intersection. This is what you have. So now we're going to try it out on the number line. So we know what your A is. Your A, we can start with B intersection C. B is -3 to 3. Yeah, so there's a -3 to 3. This is closed on both ends. This is your B. Then I'll use red for your C. Your C is -1. -1 is in between here, -1 to 6, which is closed at -1 and open at 6. Yeah, this is your C. So the intersection is going to be negative 1 to 3 closed on both ends. That's this. That's B intersection C. Now they want the complement. So what is outside? Negative 1, 3. So what is outside is going to be from here, from negative 1 going this side, and also from 3 going this side. This is B intersection C with a complement. Is this okay, guys? Is everyone okay here? Anyone who has any question here? Okay, so hope that's okay. So now we can just erase this just to make life easy. Then we can now put the A. We know what A is. A is from negative 7, then up to positive 3. Yeah, and it's open on both ends. This is what you have. Now, if this is our A, they're asking for the intersection. So the intersection here is just going to be this part alone, just this part from here, because it's open there. So we'll just say this is the same as negative 7 up to negative 1, open as well. So we cannot even add this because 3 is open on both ends. It's not in B intersection C complement, and it's also not in A. Yeah, but if it was closed and closed here, would have added this to say union. We put a discrete set, would have put 3 like this, but then it's not in both sets. We're looking for intersection, right? What's common between B intersection C complement and A? So what's on a common is negative 7 to negative 1. Any questions, guys, here? Your number 2, they said simplify and express this in the form of P plus Q root 2, where P and Q are rational numbers. So they already give you how it's supposed to come out. They just want you to tell them what the P and the Q are supposed to be by the time you're done solving. Yeah, so the first thing you do is to expand the denominator, because there's a 2 there. They're saying this guy at the bottom is supposed to multiply itself twice. So that's B1. So B1, we're having 4. There's a 3 minus root 2. So I'll just expand the bottom part. So you can do it step by step to avoid making mistakes. We're saying root 2, multiplying another root 2. Yeah, so this is going to be 4. Then this times that, that's going to be a 9. Then minus 3, root 2. Then this is going to be minus 3, root 2. Then this is going to be plus a 2. Is everyone okay here, guys? I just multiplied 3 by 3. 3. And this by that, then this by that. Then from here, so this and this guy is what became positive 2. Yeah, so this now is going to be 9, 10, 11. So that's going to be 11 minus 6 root 2, because these were like terms. Then from here we rationalize, because we don't want to see the root down. So rationalize with root 11 plus 6 root 2, and also 11 plus 6 root 2. So now the guy on top is going to be 44, then plus a 24, root of 2. I'm just multiplying 4 by this, 4 by that. Then the bottom part is just going to be 121, then minus a 36 minus 2. Hope you're okay. I just multiplied 11 times 11, that's 121. Then negative 6 root 2 times positive 6 root 2, that's negative this, then root 4. This is how it's becoming that. So this is going to be a 72. So we're having 44 plus 24 root of 2. Down you have 121 minus a 72. So this is just going to give us the 121 minus 72 is going to give us a 49. So we're having a 44 plus a 24 root 2. This is supposed to be everything over a 49. If I'm not mistaken, then this can be split it into 4 over 49, then plus 24 over 49, then root 2. We can reduce, can we reduce this? Any number that can go there? Look at the last digits. There's a 4, there's a 9. There's no number that can divide 4 and 9 without leaving a remainder. Then here I can I use 3? Can 3 work here? Is there anything that can work? No. There shouldn't be any number that should work because it's the same case. Yeah, so this again won't work, so just a waste of time. We'll just go direct and say where P is 44 over 49 and the Q is 24 over 49, because they already knew about the root 2. They wanted this to be in this form, right? Just tell them the P, tell them the Q. That's what they wanted. And they knew that there will be rational numbers. They will be in fraction form. So this is just proving to be correct. Any questions, guys? Any questions here? So for those joining, I said we're starting with the 1100 paper because it was easy. So we're just going to wrap it up, then also to do the 1120 because the 1120 was a bit bulky. So this is part A of 1B. Then the last one here, they're saying given that root 2 is irrational, show that this is also irrational. So this is only applicable for those doing 1100. Yeah, so they want us to show, they have already said that root what? They said given that root 3 is irrational. They already told us that this is irrational from the statement, the first one. We need to show that root 3 minus 2 is also irrational. Yeah, so the first thing that you do, this is one of the simplest proofs you can ever have. So you assume, you write this. So assume root 3 minus 2 is rational. That's the first assumption you make, meaning it can be put in the form of A over B. So we're just going to say root 3 minus this is the same as A over B, where A and B have no common factor. That's what we know. That's the definition of a rational number, right? And B is also not equal to 0. That's what we should know. So now we take this. We're going to take root 3 minus 2 and solve it. This is just going to be root 3 is equal to A over B plus 2. Then this here, if you combine this side, your right-hand side, your common denominator is B. This is just going to be A plus 2B. You notice that this is a contradiction. This is a contradiction because root 3 is irrational as earlier stated. They already told us that this guy is irrational, meaning it cannot be put in a fraction form. So here we're having a contradiction because the left-hand side is irrational. That's what they said, according to what they said. The right-hand side is rational. This is in a fraction form. It's a rational expression. This is rational. Something irrational cannot be equal to something that's rational. So you establish the contradiction just right here. Hence, shown. So you conclude, you say, hence, it has failed to be a rational number. So meaning it's automatically what? An irrational number. Hence, this is irrational. This is what you were supposed to do to score your 4 marks on B2. Any questions, guys? Those that are doing 1100. Any questions here?
No questions, sir.
Okay, no questions. So we can proceed to the next one. This is on complex numbers. So this is very straightforward. You just multiply the top part. So when you multiply the top part, I'll just do it here, right here on this page. So under complex numbers, you know to say there are only few things you need to master. I squared is called -1. If you're given a complex number, which looks like this, meaning its conjugate is just equal to x minus iy, then the modulus of that same complex number is just the square root of the x value and the y value. So here, they want it in this form, so we'll multiply the top part. That's going to give me 6 plus 9i. Then I times 2, that's -2i. -i times 3i, that was supposed to be -3i squared. But because I squared is -1, -1 times -3, that's going to give us a +3. Down part, you just have 1 plus I. Then this will just be 9 minus 7i or plus 7i. Then you have 1 plus I. You conjugate here, multiply with the conjugate. So when you multiply this, because this is what, 9, right? That's going to be, 7. So if we do this, we are having a 9 plus 7i. Then we are having a 1 plus I, 1 minus I, and 1 minus I. The numerator here is going to be 9 minus 9i, then plus 7i then positive 7, then down you just get 1 plus 1. This will just be 16, then minus 2i. This is just a 2. This will just end up giving this. So they already knew that it was going to be like this. We tell them what the p is. P will be 8 and the q will be negative 1. The coefficient of I, what's in front of I. So this is what you were supposed to get on number 2, question 2a. Hope this is okay, guys. Any questions up to this point? Beauty, this is okay, you're following?
Yes.
Okay, so now the other part here, which is also, so you see the marks allocation was really fair because they were giving so much marks for little or almost no work. Here is you have Z1 and Z2. They want us to get the modulus of Z1 and Z2. You know what modulus is? I'm just from giving us the expression here. Modulus of any Z is just you doing this. This is basically what they want. So we're simply going to multiply Z1 and Z2. That's what they mean first. Multiply them first, then I'll get the modulus. So Z1, however you show it, we're just saying Z1 and Z2 is simply the same as Z1 is 2 plus I, then Z2 is 3 minus 2I. That then when we simply multiply, that's going to be 4I, then plus 3I, then plus 2. By now, guys, you should be okay with seeing the I disappearing whenever it's going to form I squared. Then this is minus that. This is what we're getting. So this is going to be 8 squared and negative 1 squared. So this is going to give us what, 64 plus 1. That's going to give you a 65. Yeah, so you're getting a 65. Is 65 perfect? Is there any number that we can use for 65? No. Maybe 5, but assume it won't make any sense because 5, that will be 5 by 13 if I'm not mistaken. Yeah, but then there is no perfect number that can reduce this, so we just leave it like this. This is basically what you get. That's the modulus of Z1 and Z2. Hope that's okay. Yeah, this is what you had. Then the next question on 2. So 2, they gave 2b, it was a function. They're saying f of x and you're having g of x. They want us to compose g of f, then now state the domain. That's what you have. Yeah, so we're going to get, we're getting f and putting it in g. That's what we have. Then we compose it now. Already you're seeing here, so we're saying g of f, right? So g of f. So we know that f of x is equal to x minus 2 and g of x is equal to 1 over x squared. So if we say g of h, this is going to be 1 over, where there's x there, we put f, the function f, square it. This is just the same as x minus 2, then square it. This is going to be 1. This is going to give us what? This is just going to, okay, it's okay. You can expand it or just leave it like this. It's still okay. This is going to give us what? Plus 4. So this is what you get. This is g of f. Then what's the domain here? The domain is all numbers except numbers that can make the down part to be 0, and we can take it from where we had it there before we expanded it. What can make this to be 0? When you square root both sides, x minus 2 is equal to 0, meaning x is equal to 2. Only x is equal to 2 can make this guy to be 0, meaning the domain is just all real numbers, but x should not be equal to a 2. Is this okay, guys? Am I too fast? Any questions here?
Sir, can you repeat on
the question?
Yes. Okay, so first of all, Beauty, which part should I repeat before Christopher asks the question?
The part for the domain where you are squaring the x minus 2 over the power of 2.
Okay, are you okay on how we landed on this thing here? This one here? Where we replaced. Okay, we're saying we are getting f and putting it in g, right?
Yes.
Then when we put your x minus 2 there, we're squaring it, right? There's a 2 there. So x minus 2 squared. When this guy multiplies itself twice, it's giving us this guy. This is what we are getting. This guy in red. It's okay? Now I'm saying this part here, maybe let me use blue. This part here, x minus 2 squared, this thing here is exactly the same as this. So instead of me trying to solve this using product sum of factor or the quadratic bus equation, I'm just deciding to solve the initial thing, what it was before it became so big, which is just x minus 2 squared. And if we try to solve it, so the x minus 2 to the power 2, before even expand it, we're saying we can solve it right here. We're just square rooting both sides to cancel the 2 so that it becomes x minus 2, which is now that. That's how we're getting the 2 to be 0. I mean x to be 2. The number that can make the whole thing to be 0 is when x is equal to 2. No wonder we're saying, since the only number that can make the denominator to be 0 is 2, we're saying all numbers should be allowed, but not that number, which is 2. So that's going to be our domain. This exactly here is our domain. All real numbers, but not x being equal to 2. Is this too confusing, Madam Beauty?
No, it's not.
It's okay?
Yes.
So now Chris, you had a question.
Yes, my question was, since they said we find g of f, then once we find g of f, that's when we can determine our domain. So in my case, since this is a quadratic equation, me I just wrote all real numbers.
Oh, now, okay. That's
I'm confused.
That's the confusion that most people come up with. So yes, what we got down here is a quadratic, but then this thing is mixed. It's not a single quadratic. It's not alone. Unless if it was alone, imagine if you had how can I put it? Or if it was like this, what you're saying could have worked if f of x is equal to x minus 2. Then I give you g of x is equal to x squared. There is no 1 over that, it's just x squared. Meaning if I give you g of x and g of f, that's going to be x minus 2 squared. This is going to be x. Your answer would have been correct if there was no 1, but they mixed things now. They added, there was a 1 there. So meaning, yaboya change yankala, rational function mixed with a quadratic. It's like those things under asymptotes. How do you get your vertical asymptote here? Vertical asymptote is you solving the down part, right? So when you solve the down part here, the only root you are getting is 2. So we're saying this is our vertical asymptote, meaning this is the number that we're just not allowed to touch, but we can touch everything else. So that's how the domain is becoming all real numbers, but not 2. But if it was just like this, like without the 1 on top, your answer would have been right, because it would have been a normal innocent quadratic, because yankala quadratic function, but this is not a quadratic. When they put a 1, it's no longer a quadratic, it's now a rational function that is in the form of p over q.
No problem, sir. I understand now.
So please don't have emotions in case mambona tutambonkala wrong. Yeah, so you have this. This is how you do it here, Chris. Yeah, as soon as you have this, as long as there's something on top and the quadratic is down, because if we just say all real numbers, meaning we're just considering the guy at the bottom. So we're saying all numbers allowed. What if we put a 2 there, meaning it's going to be this? This is undefined. It's an error on the calculator. We're unable to solve this. Yeah, so it would be incorrect to say that. Yeah, so this is okay. Then the second one here, they are saying sketch the graph. Sketch the graph of the curve, this guy here given, and state the asymptotes, if any. So this is what we have. This is a normal typical case 1. Is it case 1 or case 2? Rational function where we're saying they're of the same degree. We are saying y is equal to x plus 1, and you're having x plus 2. So according to this, what's the domain, guys, here? All real numbers, but not what? What's the domain? What did you say the domain is, guys, here?
-2.
All numbers, but not -2. We solve the down part. The domain always just solve the down part. All numbers, but not the guy that is making the down part to be 0. So when you solve this, you are getting a -2. This number is not allowed. So this will turn out to be what we call a vertical asymptote. x is equal to -2 is the vertical asymptote, the number we should never touch on the x-axis. Then for the range, we said whenever they're of the same degree, the range is going to be the coefficients of x in the numerator divided by the coefficient of x in the denominator. So it's all numbers but not 1. 1 over 1. There's a 1 there, there's a 1, so that's where the 1 is coming from. Yeah. Other people say, no, get the inverse first, then the domain of the inverse is going to be the range of the original function. It's still the same thing, you'll get the same answer. So this is going to be the horizontal asymptote, the number that we are not supposed to touch on the y-axis. This is what we are having. Then once you have these two, it's easy for you to get your x and y intercept. So you're just going to put something like this, x and y intercept, to make life easy. Give yourself x, give yourself, put a 0 there, put a 0 there. When x is 0, what do you get? You get 1 over 2. When 0 is put on y, you are simply going to get a -1 as the value of x. If we put 0 on y, right, and solve this to be 0 is equal to x plus 1, then you have x plus 2. Cross multiply, this will just be 0 is equal to x plus 1. Take the 1 this side, that's where the -1 is coming from. Yeah, so now that we have the domain, the range, the asymptotes, so we are saying -2 should not be touched on the x-axis. So -2 is the vertical asymptote. We should never touch this guy. That's what we have. Then 1 should also never be touched on the y-axis. We should never touch this guy. Then the numbers that we should touch on the x and y are the asymptotes. These guys here, 0,5. So 0,5 is somewhere there. That's half of the y. Then the other one is negative what? The other guy is 0,1 on the x. -1, 0, -1. So meaning we have to touch this point. These 2 points have to be touched, this point and this point. Then the twin is going to be automatic. The twin is going to be in the other region, opposite region. That's why the twin is going to be thrown. Any questions, guys, here? Yeah, so that answers our question here. So this is what you are supposed to do. Yeah, get your sum, your product, then we get the new quadratic. This is what you get. Then I'll look at this one here. They're simply saying, question 3, 3, 2, and this is the same thing. You notice the question is the same thing, except the first part, they just want you to complete the square. That's all, your 5 marks. Then the second part, they want you to actually sketch it, indicating the turning point and the x and the y intercept. That's a total of 11 marks. So we're simply going to do this at once. We do everything together. That's simply going to be, that's x, that's f of x. F of x is equal to, you're having x squared minus 6x then plus 18. So the first thing that we do here is just halving this. You see there's a 1 here, right? You half the second term. If there's already a 1, there's nothing to factorize. Just half the 6. That's going to be 3. Then put it like this. Minus the square of this number here, which is that, then plus 18. So this is just going to be x minus 3 squared minus 9, then plus 18. This will simply give us x minus 3 squared then plus a 9. This is what you get. So the turning point, according to this, is 3,9, because if you solve what's inside here, you get a 3, then get what's outside there, that's that. So already this should tell you something, because if you check, the discriminant of this question is not a normal one that we expect to get, because if you put your b is -6 squared minus 4 ac, this is going to give us 36. When you multiply this, that's going to give us a 72. This is -36. That's what you're getting. So we are unable to solve this, and it won't even make sense because the discriminant we're getting is less than 0, meaning this thing doesn't have roots. Look at the turning point. The turning point is 3,9. So there's a 3, then there's a 9 there. And the value is simply what? The value is simply telling us the value of a. A is greater than 0, so the graph has to look like this. And we're supposed to touch the y-axis at 18. So x-intercept, you say do not exist. X-intercept, you say DNE. We are never going to touch the x-axis. Then the y-intercept, it's a constant in the question, which is y is equal to 18. So this is how the graph was supposed to be. This is answering your two questions on number 3. Yeah, so this is what was needed. This answers these two, guys. Any questions, guys, here? This was never touching the x-axis. So if you got answers, then meaning you made a mistake somewhere.
Sir, but how can you know that this won't have roots, that it won't have roots in the x-axis?
You use the discriminant. The discriminant, remember, tells you the nature of the roots, right? Remember, I'll say if the discriminant is greater than this, meaning you have two real roots. Remember that thing? If you say for this is equal to 0, meaning you have one real root. Yeah, so we're using the discriminant. Or rather, simply put, try to solve it. Use the Chima formula, Chima bus. X is equal to negative this. When you try to solve this, b squared 4ac. Let's see if we're able to solve this. Can we solve it? No, we won't be able to, because the answer inside here is negative 36. There's nothing that we can do with a negative 36, so it cannot give us answers. It doesn't have real answers. So we're not touching the x-axis. And also, where is your turning point? Your turning point is 3,9 and a is greater than 0. We expect it to be a minimum, so meaning it has to face up. So if we're turning up, we're facing up and we're turning from 3,9, already that should tell you something, because we'll never touch the x-axis if we turn up, unless if we're turning down. Is this okay, or it's confusing?
Yes, it is okay, but though in the when I was writing, I was a bit confused. I don't even know what I wrote.
Oh yeah, so I think they just did it deliberately because they knew people would actually force things. So if you actually got the correct completed square version, it should have told you something, because this is the correct completed square form. If you want to get the x-intercept, you can just equate this to 0. If you try to solve it, just right here, if you try to solve it, I think it's supposed to be, let me check, 4 by 18, that's 72. Yeah, it's supposed to be here. If you just try to solve it here, it will be impossible for you to solve this. We cannot find the square root of negative 9. So already it will fail just right here. So you know to say, oh, then the graph has no x-intercepts. It just goes up, where this guy here is our 18. Yeah, so this is the correct answer to number 3A. That's what was needed for the whole 11 marks. Just showing everything at once would have been better. Then the last question on number 3 here, they're saying the quadratic, this has two different real roots. Find the possible values of k. So if it has two different real roots, simply means the discriminant 4ac is greater than what? Greater than 0. That's what we're going to do. We're going to replace your a, which is k, your b, which is 4, your c, which is 5 minus k, into this, and then solve it. So if we put our expression there, if we put it to be, we're saying the expression given is, there's k squared, there's plus 4x x squared, then you have 5 minus k is equal to 0. So our a is k, our b is 4, our c is 5 minus k. So now if we do the replacements, we're saying this has to be less than what? I mean greater than, sorry. It has to be greater than 0 because there are two real roots. So this is going to be 16, 4 there, then 4, a, then we're having 5 minus k. This is going to be 16 minus 20k when you multiply this by 5, then positive 4k squared. This is just going to be 4k squared minus 20k plus 16. You can just equate it to 0. This will come later on, so that when you solve this now, we can divide everything by 4 to just lessen the burden. This is going to be like this. When you solve this, k squared minus, you can say 4k minus 1. K, this is plus 4. This is going to be k minus 4, and also minus k minus 4. This is a 1 there, by the way. So we're having k minus 1 and we're having k minus 4. So we're getting two answers, right? There's a 1 and there's also a 4. Yeah, so to make life easy, I'll just solve this at once. So we're saying this has to be what? To be greater than 0. So if we say this has to be greater than 0, we can say there's a 1 there, then there is a 4 there. When we solve this guy here, when we put any number this side, let's say 0, when you put a 0 there and a 0 there, this is -1 and then -4. The answer you're getting is 4. Is it greater than 0? That's true. This will be false. That's going to be true, I suppose. If you use any number, let's say 2, that's 1, that's -2, that will be less than 0, right? Don't be greater than 0, so this will be negative, positive, negative, and positive. When you use a 5, then it will work out. Yeah, so the correct answer is that k has to belong to -infinity up to 1, union from 4 up to +infinity. K can come from any of these two sets, and the answer will have two different roots. Any questions, guys, here? Is this okay? Any questions here?
So, sir, this question also had to go for even in finding the critical values and stuff like that.
Yes, whenever it's an inequality, because a discriminant is an inequality, you always have to use critical values. You always have to test, provided it's an inequality, yes.
Alright.
Yeah, so that was what was supposed to be done. Then the next question here, they're saying use long division to divide the polynomial. This is what you're having here. So the polynomial is simply here to the power 3, then the divisor is there. They just wanted you to divide that, so using long division. So we're supposed to show the remainder and the quotient. So if we do that, we're just supposed to have, okay, so here the polynomial is, okay, 2x. We start with the divisor, minus x, then plus 3. So the divisor is okay in terms of the powers of x, they're just properly descending. But then our polynomial is missing something. There is no x to the power 2 there. It's just 2x to the power 3. So we'll put a place value for that, which is x squared. Then we're now going to say minus 10x. Then we're going to say plus a 24. That's what you get. Yeah, so always make sure that the powers of x are supposed to be descending. When you divide 2x squared into 2x cubed, that's just going to be x, then multiply. This will be 2x cubed, then minus x squared, then plus 3x. Then here now we can find the difference. This is going to give us x squared. Then we are having, this is going to be a minus 13. So be careful with the negatives. Negative 10x minus 3x. This will be that. Bring down the 24. Then here, still divide. These guys are of the same degree, so they can still divide. 2x into 1x is going to be x squared. We're dividing x squared divided by 2x, right? This is just going to give us half. So what remains there is just 1 over 2. Then you multiply this by that. That's going to be x squared. This is going to be half x. Then this is going to be plus 3 over 2. This disappears when you subtract. This is just going to give us negative 12.5 x. Then 24 minus 1.5. That's going to give us 24 1.5. That's 23. That's going to be 22.5. You can just say 22.5. So yeah, you have your quotient, then you have your remainder. So most people are making mistakes on the half. I don't know why they were doubting it, or I don't know what was happening, but this is what you were supposed to get. The quotient is here.
We are doubting that one up.
Oh yeah. So
When you on the same half.
When you divide 1 divided by 2, what do you get? We cannot reduce it, right? We're dividing this, we're saying x squared divided by 2x squared. So we're saying this into that. Yeah, so this is what we're doing here. The x squared will go away. What will remain will just 1 over 2. So that's the 1 over 2 that we're putting there as our quotient. Then everything else gets affected by the half. Half of 2 is 1. Half of 1 is half. Half of 3 is just 1.5. So this is now what we're getting. Then we finish it off. Okay, so that explains your last question on number 3. Then number 4 was under polynomials. They said a function is defined by f of x where a and b are constants. The remainder f of x is divided by x minus 2 is equal to the remainder when this is divided by that. So they are saying find the value of a. So the remainder is the same when you divide the polynomial by x minus 2 and also by x plus 1. That's what they are saying. So we're simply going to solve this. This gives you x is equal to 2. When you put it in the function, it should give you the same thing as someone who solves this -1 and puts the same function, because the remainder is supposed to be the same. That's what they are saying. The value of the remainder is supposed to be the same, right? So this, the same what we equated. So we're going to put this will be here. So the polynomial is given to be f of x, x to the power 4, then plus 5, x to the power 3, then plus a, x, then plus b. So we're putting x minus 2 and also x plus 1. This is just going to give us x is equal to 2. And this is going to give us x is equal to -1. So we put 2 there. That's a 2 to the power 4 plus 5. This is a 2 to the power 3 plus a 2a, then plus b is equal to, when you put a -1, that's a -1 to the power 4 plus 5, -1 to the power 3 plus -1a, then plus b. That's what we are having. You notice that the b is going to cancel because it's appearing on both sides without anything. So b comes this side, it will cancel, right? This is going to be 2 to the power 4, that's going to be 16, plus this is going to be 8 by 5, that's going to be 40, plus 2a is equal to, this is going to give us a 1, minus a 5, and minus a. You will notice that when the a comes this side, it's going to be 3a, this is going to be -4, then this is going to be supposed to be a 56, goes this side, becomes -56, so we're having 3a is equal to -60, divide by 3, so a is supposed to be -20. Hope you're okay here, guys. We're using the remainder theorem. They're saying the remainder when this is divided by x minus 2 is equal to the remainder when f of x is divided by x plus 1. So that's basically what you get. They're the same. So that gives us the value of a. Once you know your a, you should be able to get the value of b, because here they're now proceeding and asking us about b. So we know what a is. A is, from getting it, this is simply your what? This is just your what? Or this is negative, or this is positive. It's supposed to be negative there. Yeah, so your a is -20. So if you put your -20 there, now you can get, they're saying, given also this is a factor, find the value of b. So meaning x is equal to -3 is a factor, which leaves a remainder of 0 whenever put in the whole expression. So we're saying, if we know what a is, we know f of x is equal to x to the power 4 plus 5x to the power 3, then plus, or -20. We know what a is. Then this is going to be plus b. We know to say this is a factor, so we put it there. That's -3 to the power 4 plus 5, -3 to the power 3 minus 20, -3 plus b is equal to 0 because it's a factor. This here will just give us 81. This here is going to give us minus, that's going to be a 27 by 5, that's 135 plus a 60 plus b is equal to 0. So we're saying 81 minus 135 then plus a 60, that's a 6. Meaning b was equal to -6 as well. So you found this. Yeah, and you're done with that guy. Hope this is okay, guys. We're now on the last question, B, 4B1. So 4B1, we've done something like this before. We said the first thing that you do is moving one side, one square root on one side. This is applicable to everyone, both doing 1120 and 1100. This is the same principle. We're saying take one on the other side. You cannot square here both sides and say this cancels with these two. That's wrong. Yeah, I've seen some people doing that. That's wrong. So the only thing we can do here is take one on the other side. This is going to be 2x plus 3 is equal to 2 plus root of x minus 2. Then from here now you can square both sides. When you do, this is going to be 2x plus 3 is equal to this times itself twice. To avoid making mistakes, you can write everything at the same time. Then just expand it. This is going to be 2x plus 3. This is going to be 4 plus 2, x minus that, plus 2, x minus that, then plus this times that, x minus 2. We take everything that doesn't have the square root on the same side. So when you take x, this side is going to be 3x. When you take 2 or 4 minus this 4 and this 2 can give us 2. When you take it this side, it will be negative 2. So this is just going to be a 1 because 3 minus 2, right? Then here we're having 2 root that. So we are going to get 4 root x minus that. Then from here you can square both sides. 3x plus 1 squared is equal to 4x this. This here will give us 9x plus 6x plus 1. This side will give you 16 and x minus 2. So this is just going to give us, this is supposed to give us 9 squared, 9x squared plus 6x plus 1 is 16x, then minus 32. Then 9x squared, this comes this side to be 10x. It's going to be 31 is equal to that. Yeah, so this is what we are getting. When you multiply this, we get what? This is 9 by, how is it 31? This is 32. Oh, it's going to be plus, guys. This is going to be 33, right? Yeah, when you move this side, this is 32. Negative comes this side, it's going to add. So they are going to be, it's going to be a 33. Then how about the x, this guy here? Okay, so if we multiply these two, I'm not sure, this is going to be 9 by 33. That's okay. This is going to be, it was not supposed to be like this. It's supposed to be something simpler. This is 2x here. And we're getting x is going to be plus 3. Okay. Okay, so are you guys seeing anywhere where I've made a mistake here? Are you able to spot any mistake that I've made? Is this okay? Because now from here, if we try to solve this, let me just confirm this. If you try to solve using the Chimapas, this is going to be 100 minus your 4. This won't work out because this is going to be, this is 29. So that's why I'm saying I've made a mistake somewhere. I'm trying to spot it. Because here, when we square this side, this is going to give us 2x plus 3. This is a 2. And this is going to be a 4. And this will be a 2. That's okay. This will be, or this will be, okay, this is a plus here, guys. Sorry, this is a plus, right? X minus 2, root of x minus 2 times root of x minus 2 will give us plus x minus 2. So when we multiply them, it's going to be plus x minus 2, meaning when we take the x on the other side, it's supposed to reduce. So this whole part here is a mistake. Yeah, when we take this on the other side, it's supposed to be x. Then 3 minus this, that's negative 1. Negative 1 plus this, that's going to be positive 1. Yeah, so this is what is supposed to happen. We're supposed to only have x plus 1 is equal to 4. Then x minus 2. Then here when you square both sides, this now, yes, this is going to be solvable. Yeah, this is going to be 16x, then minus 32. That's how we reach on, this is supposed to be minus 14x, then this is going to be 33. This is the correct working. And this here will just give us minus, this is 33, we're saying 11x minus 3x plus the 33 is equal to 0, so x minus 11. Then you're having negative 3, then you're having x minus 11 is equal to 0. So x is equal to 11 and x is equal to a 3. So these are the two answers, and when you test, they will both work out. This is what you are supposed to get. Any questions, guys? Are you guys still following, or maybe you're tired? Any questions, guys, here? It's okay. Okay, so if this is okay, we can do the last part. The last part is simply here. They're simply telling us to say we need to solve this. Find the set of values for x where this is less than 2. So the easiest thing to do here, where they've given you x minus 2 and also x plus 4 is x plus 4. This whole thing is less than a 2. So the first proper thing to do here is to remove the modulus expressions, or even distribute them. It's okay to just distribute them. You can just write it like this. This is x minus 2, then you're having x plus 4, and this is less than a 2. You can now just change it to be x minus 2, and down you have x plus 4. Change it into an equal sign. So this is a 2 there, then cross multiply. This is going to be x minus 2. This is the easiest path. Instead of doing cases, you can just have something like this. Then now you can square both sides. This is going to give us x minus 2 is equal to, there's a 2 squared and also x plus 4 squared. This will be x squared minus 4x plus 4. There will be 4. There will be x squared plus, this is 8x plus 16. Then from here we can just gather like terms. This is going to be 4x plus 4, then is equal to, this is 4x squared. 4 by 8, that's going to give us a 32x. Then you're having 4 by 16. So 16 by 4, that should give us 64 or something. Yeah, 64. Then from here, we're going to take these things, this side on the other side. This is going to land us into 3x squared. Then this is going to be a 36x. Then when you take the 4 this side, this is just going to give you 60. That's what you get. Then divide everything by 3. This is just going to be 12x. Then this is supposed to be 3 there. That should be 3 there. That's a 20. This is supposed to be that. So what numbers can multiply to give us a 20? So this is just supposed to be 10x plus 2x. Yeah, this is going to be 20 is equal to 0. So we're getting our answers. When you're done solving this, you get your answers to be x plus 10. The answers are negative 10, and there's a 2 as well, negative 2. So now we're going to test. We come back here, we test. The proper question was this. This is the original question that we are given. Now we're just saying we're testing between negative 10 and negative 2. So if you choose any number less than negative 10, let's say negative 20 for instance, you put it here on top. This is going to give us negative 22, modulus that's just 22. Then down, this is going to be negative 16, modulus just gives you 16. Is this number less than 2? So we try to reduce it. That's 11 over 16, over 8. So if you try to divide 11, divide by 8, that should be 1 point something. So this number, yes, is less than 2. That's true, right? Any number here, okay, this is supposed to be, yes, this is okay. Any number here in between, let's say negative 5. If I use negative 5, that's going to give me a 7. Negative 5, that's going to give me That's going to give me a 1. So if I say 7, is it greater than, so this is false. This is not less than 2, right? Yeah, I try anything this side 0, that's going to give us 2 over 4. Is it less than 2? Yes, this is just going to be half. Yeah. So the answer is just that x must come from negative infinity up to negative 10, open, then from negative 2 to positive infinity. This right here should be your answer. That satisfies the inequality. This guy here. However you do it, those are supposed to be your outcomes. So this is what you're supposed to do. No wonder it was carrying 8 marks because of the working that was needed. Any questions, guys, here?